Good morning. Today I am going to share with you differential form of Ampere's law. So let us see. If S be any open surface with its boundary formed by a curve C, then from Stokes' theorem we can say closed line integral B dot dl equal to open surface integral del cross B dot ds. This is equation 1. Here B is a vector and here B is magnetic field, and from Stokes' theorem we can write this. Stokes' theorem is the relation between closed line integral of a vector with closed open surface integral of curl of that vector, and the closed line is the boundary of the open surface. Before discussing differential form of Ampere's law, we first discuss about what is open surface. If you take a bowl, this is an example of open surface, and any kind of open surface is bounded by a closed curve. If you take a bowl, then if you see its edge is a circle and it is a closed curve or it is a closed line. So a closed line is always associated with an open surface. If you take a cup, this is also an example of an open surface, and there is also a closed curve or closed line, its boundary, its edge. If you take a glass, its edge is a circle and that is a closed curve or closed line. An closed line may be a circle or may not be a circle. If you take a broken coconut, it's also an example of open surface, and its rough boundary, its rough edge is also a closed curve or closed line, and it is not a circle but it is a closed line, and it is associated with that open surface. Here this open surface is denoted by S, and a closed curve which is associated with this closed curve, open surface, is closed curve is associated with this open surface is denoted by C. A whole coconut is an example of closed surface, but a broken coconut is an example of open surface, and a closed line is always associated with an open surface. So this is discussion about what is open surface and what is closed surface and what is boundary of an open surface. A boundary of an open surface always a closed curve, and Stokes' theorem gives the relation between closed line integral of a vector and open surface integral of the curl of that vector. Here the vector is magnetic field B, and this is a symbol of closed line integral. This is a symbol first, this is integration, and a circle is there. This symbol and a C for closed line, closed actually. This symbol is, this is a symbol of closed line, and this is a symbol of open surface. This is a integration and S at the suffix of this integration. So this is equation 1, and next we see, if J be the current density, then total current I flowing through an open surface S is I equal to open surface integral J dot ds. This is equation 2. This is relation between current density and current through the open surface S. Now from Ampere's circuital law, we know that closed line integral B dot dl equal to mu 0 times I, where mu 0 is the magnetic permeability of free space, and here I is the current associated with the open surface, and which is also equal to I equal to open surface integral J dot ds, which is given by equation 2. Now in right hand side of Ampere's law, in place of I we can write I equal to open surface integral J dot ds, which is given by equation 2. So next step, we write at the right hand side of this Ampere's law, in place of I, open surface integral J dot ds. And here mu 0 is the constant, and in the left hand side we can write from equation 1 closed line integral B dot dl equal to this. So in place of closed line integral B dot dl, we can write open surface integral curl of B dot ds. So we write here at the left hand side of Ampere's circuital law, open surface integral curl of B dot ds, which equal to open surface integral mu 0 times J dot ds. If we take now the right hand side into the left hand side in next step, then we can easily write that open surface integral del cross B minus mu 0 times J dot ds equal to 0. Since this is true for any surface S, that is open surface S with C as a boundary, then the integrand must be 0, otherwise it is not possible. That is del cross B minus mu 0 J equal to 0, and we can easily say del cross B equal to mu 0 J. This is differential form of Ampere's law. So this was the discussion today, differential form of Ampere's law, and thank you for watching this video. Thank you again.